So children, taking up the second class on the chapter sound. We had already started the chapter sound. I told you a few basic things regarding sound, that how sound is produced, the velocity of sound, the need for a material medium for the propagation of sound. All these things we had discussed. Let's move a step ahead further regarding sound, and what we'll be dealing is the common terms. I think so I told about the common term also. Particles, vibration, to and fro motion, all these things we had discussed. So it will be our chapter name is sound, and it is the lecture 7th chapter I am teaching you, and second lecture of that. Now see here, common terms used in sound. Using sound. Now see here, I have told you about to and fro mean position, from the mean position, that called as vibration. So I have told you already about vibration. What is vibration? Whenever there is a particle and that particle is having to and fro motion about the mean position. This definition that is given in the book is with regard to the tuning fork. So there is a tuning fork. Here, these are prongs. U-shape. This is the handle. So when you strike this prong with a rubber pad, then this prong will start vibrating, and they will move to and fro. Okay, you can do it and find it. So they will move, and the position of the one arm of the prong is mean position, in which they are resting. Means that position they will always pass through. So these are the two extreme positions, and this is the mean position. Okay. So this already I have discussed. Now taking up the next term, that is amplitude. Amplitude you have already learned, and again you will be learning about amplitude in the class 9. But as of now, I am taking the term as amplitude. See, amplitude is what? Always defined with respect to the mean position. Amplitude is always defined with respect to mean position. Suppose I am drawing a wave like this. This should be a identical one. So this is the time coordinate, and this is the displacement coordinate. So see here, this is the maximum displacement. See here, particles is the mean position. So this is the mean position. From the mean position, the maximum, see, from the minimum it starts, that means from 0 it starts. Then the position of particles from the mean position increases, displacement increases. This is the maxima, or you can say the maxima associated with it. Okay? So this is the maximum position or maximum displacement that a particle can have. Now see, this is the positive direction, this is the negative direction. But we are taking the modulus of it. So it will be what? This is the maximum displacement. This one is called as amplitude. What I have drawn? I have drawn a wave. So this wave is the way in which the traveling is the sound are waves. Sound is the wave, na? So sound is wave, so it will travel this way. So they will travel like this. It is a different case that there are two modes of propagation. So a wave can be longitudinal and transverse. That we have done already in class 7th. So here amplitude. So when we talk about amplitude, this should be this is the maxima and this is the minima. But see, if you talk about displacement, it should be a modulus. So this is the maximum. This is the maximum. It is the negative direction, it is the positive direction. Above is positive, below is negative. If you have done about coordinate axis, coordinate plotting of the points in mathematics, you must have done. So now, what is amplitude? So the maximum displacement in the case of tuning fork. So it is the with help of this amplitude, always you have to learn about one term that is called as maximum displacement. Maximum displacement. That means there has to be a mean position, and for that mean position, from that mean position, the maximum displacement is called as amplitude. Okay? So these are all things that are telling with respect to the tuning fork. So if you are talking tuning fork, because they have so only maximum displacement won't help you. You have to write from mean position. Mean position is called as the amplitude. So suppose I'm just drawing a very big figure for the tuning fork, one of the arms, and if these two are the extreme positions, so this and this are your extremes or extreme positions. This is your mean position. So from one mean to extreme, this is the maximum displacement. This side and this side. So if this, as per your book, what they are giving the name, let us name that only. So if A is the mean position, and on the here is B, here is C. So this AB or AC. This is symmetrical only. So it is AB or AC is the maximum displacement from the mean position. A is the mean position. So from the mean position, the maximum displacement is called as amplitude. I hope you get it now. Okay? And when I have drawn the form of a wave, because like this is your amplitude. Clear? Amplitude. So this is the way particles are moving like this. Few more things they are saying in the definition. See, if a stationary body is struck slowly or with less force, it has less amplitude. You might have come across, sometimes you are having like something, suppose this book is there and I am having, this is some sort of a metallic plate and this is a kind of a wooden hammer, and if I am doing it like this, it depends on the amount of force. Suppose I struck with the great force, the amplitude will be more. Means with more energy you are imparting here, the particles will be able to carry or they can travel more distance. So the displacement of the particles from the mean position will be more. And if you are striking this, suppose this is a plate, metallic plate, and this is a wooden hammer or like that, and you are striking it gently, then what happens? Amplitude is less. Why I have told this example? Because you can correlate it to when you are using things. Sometimes you might have seen that some temples, when you are going in temples, or sometimes in different, whenever the religious place are going, if some kind of a bell is there, not that electric bell, the bell in which you have to put your hand and there is a great structure like this. Okay, so when you are some bell, I'll draw the bell, then you understand better. Okay, you might have purchased these small bells in your birthdays also, but there this bell is there, and this is the portion. This is a small metallic bob like structure. This should be inside only, but I have drawn it outside. So when this bob is made to strike here, so you can have two methods. You can take this bob in the hand and strike it gently, and one method can be you will strike it with a greater force, a very large force. In both the cases, that when you strike it gently along these walls of this well, and when you strike it with more force, in both of the cases, the amplitude will be different. When you strike it with lesser force, amplitude will be less, and when you strike it with more force, amplitude will be more. So, as as much force you are applying for production of the sound. So you start striking the body. In the case of tuning fork, suppose I am having the tuning fork, I will strike here. If I strike gently, the amplitude will be less. If I strike it with a great force, the amplitude of the sound produced will be more. Then few more things about amplitude I will tell. What is that? Let me write that and then understand it better. If it has been found that larger the amplitude, more is the loudness. So, I think so in class 7th you have learned about this term, loudness. So, loudness is proportional to amplitude. This thing you can write in a small box. So, more is the amplitude. Amplitude of what? Amplitude of the vibration. So amplitude is always associated with some vibrations. So if the vibrations carry greater amplitude, then loudness is more. So when someone is speaking in a very slow, or you can say intensity is less, I will not use some term. So if amplitude is less, loudness is less. If amplitude is more, loudness is more. Okay, so this thing you can understand, but you will correlate it not with some sound that is electronic sound, but with some sound that you are producing mechanically. Okay, that means you have to strike somewhere, less force, loudness is less. More force, loudness is more. Okay, so that is regarding the amplitude. If a drum is hit softly, a soft sound is produced. And because so soft sound, so they use the term soft sound. You must have used drums also. You must have seen people are using the drums in the orchestras or some musical concerts or live performances by the vocalists and all. Okay, so there, what is their soft sound? You might have seen that when they are operating the drum and all, they will test it a little bit. Or sometimes in a particular song, sometimes the drum beats are less to create a different effect. Sometimes they use a greater amplitude to create a different effect. So maybe see, a song is not, but which is a periodic, but there is different effect that is produced in a sound. Sometimes, and you might have seen in the movies or songs or some acts, you might have seen that there sometimes like something surprisingly is going to happen. You can see that a great loud sound is produced, some different wave type of sound. And if the normal singing is going on, so they are using sound to create the impact of what is going on in the show, some movie or act like that. So that much you can really understand. And sometimes you don't know what is about to happen, but with the help of the sound that is being produced or the kind of music that is there, it is really understood that what is about to happen. Something good is about to come, or something terrible, or something sudden, like that, astonishing. Okay. So these are the observations you can really correlate to. Sound is a chapter in which more of understanding and observation is required and less of the definitions. So I have told you about amplitude today. So what is amplitude basically? Amplitude is the maximum displacement of the, here they have said prong, but I will say particles of the medium. Suppose it comes for simple pendulum, but what do you say? Maximum displacement of the bob from its mean position is called as amplitude. Here for the sound, maximum displacement of the vibrating tuning fork, because these definitions are given for that with respect to what? Tuning fork. So for the vibrating tuning fork from the mean position. Then what I told you? I had told you that the amplitude will vary depending on how hard you are hitting on the some material. So this tuning fork, if you are taking a body, two bodies are there, you are hitting one body to the other body. With less force, amplitude is less. Amplitude is less means what? The displacement of the particles from the mean position will be less amplitude. If you are hitting the same object, striking with greater force, amplitude of the sound will be more. Okay, that means loudness is proportional. Proportional means this is directly proportional. As much is the loudness, that much amplitude must be there. fact, we can say loudness is dependent on the amplitude of sound. So how much is the amplitude, that will decide that how much is the loudness. So that is why they are saying larger the amplitude, more the loudness. So drum hitting softly, then less amplitude, loudness is less. If the drum is hit hard, then loudness is more. So what will happen then? So this will be the thing about amplitude. I think so you have got a lot of details about amplitude. So we will continue the discussion further in the next class.